All right, welcome to The Explainer. Today, we're going to tear down a modern Android app and see what makes it tick. Seriously, we're going to dissect it, piece by piece, from what you're tapping on the screen all the way down to how it saves data on your phone. Let's get right into it.
So here's the app we're going to be working with. It's a pretty straightforward restaurant order manager. You've got a list of orders, you can see the dish, the restaurant, who's driving it, you can add new ones, you can edit them, you can delete them. It's a really classic example of what we call a data-driven app.
Okay, but that brings up the big question, right? You add a new order, you close the app, maybe you even restart your phone, and when you open it back up, the order is still there. How does that work? What's the magic happening behind the scenes to make sure that information sticks around?
Well, the answer, the secret sauce here, is a really powerful library from Android Jetpack called Room. Think of Room as Google's official recommended way to handle data locally on a device. It's basically a smart layer that sits on top of the old-school SQLite database, and it makes everything so much easier and safer to work with. Okay, so here's the game plan for this explainer. We'll start with the app's overall blueprint. Then we'll dig into the foundation, which is Room's data layer. We'll look at how we access that data using something called a DAO. Check out the UI layer, trace how data flows from end to end, and finally, we'll talk about why this whole setup is so important.
First up, let's talk about the blueprint. Before we dive into any code, we need to be super clear about what this app actually needs to do from a user's perspective. At its core, this app is really only juggling two main things: orders and drivers. An order has all the details, the restaurant, the dish, and a driver, well, that's the person assigned to deliver it. Pretty much every piece of information we're going to save fits into one of these two buckets. All right, now for the fun part. Let's get into the foundation. This is where Room steps in and really starts to build the storage part of our app. We're shifting gears now from what the app does to how it gets it done. Room is built around three main ideas, three core components. First, you've got the entity. That's basically your blueprint for a database table. Second, the DAO, which stands for Data Access Object. Think of this as your toolbox for getting data in and out. And third, you have the database itself, the big boss that holds everything together. So what exactly is an entity? Just think of it like a blueprint. In our code, it's just a simple Caughtland data class. But when you stick that little @entity annotation on top, you're giving Room a signal. You're telling it, hey, use this class to build a table in the database. And from that point on, every time you create an object from that class, boom, it becomes a new row in that table. And here's what that looks like in our code. We've got two files, order.kt and driver.kt. Both are just data classes, but notice they're both marked with @entity. The driver has a unique driver ID and a name. Simple enough. But look at the order. It has its own info, but check it out. It also has a driver ID field. That is the key. That's how we connect a specific order back to a specific driver. This diagram makes that relationship crystal clear. See the driver and order tables? In the driver table, driver ID is the primary key, or PK. That just means it's the unique number for each driver. No two drivers can have the same one. Now, look over at the order table. That same driver ID shows up again, but here it's called a foreign key, or FK. It's like a pointer, creating a direct link from an order back to its driver. This is classic database stuff, letting one driver be linked to many orders. Okay, so we've got our data all structured, nice and neat. But how do we actually do anything with it? How do we add a new order, or delete one, or find all the orders for a specific driver? That's exactly what the Data Access Object, the DAO, is for. And this leads me to one of my absolute favorite things about Room. If you've ever had to write raw SQL by hand, you know the pain. You make one tiny typo, you don't find out until your app crashes, and then you're hunting for a needle in a haystack. Room completely eliminates that problem. It actually checks your SQL queries when you're building the app at compile time, not later when it's running. It finds those mistakes before they ever get to your users. It's a lifesaver. And look how simple the code becomes because of that. All we do is create this interface, our order DAO, and we just declare what we want to do. Want to insert an order? Cool. Write a function and put @insert on it. Need to get all the orders?
Use the @query annotation and write your SQL right there. Room handles generating all the messy, behind-the-scenes code to make it work. The result is just super clean, super readable code.
All right, so we have our data storage figured out, and we have the tools to access it. Now let's move up the stack and see how all this information actually gets shown to the user on the screen. So the main screen, the main activity, is all about displaying that list of orders. To do that, it uses a standard Android thing called a recycler view, which is just really good at showing long, scrollable lists without slowing down the app. And to get the data into that list, we use a little helper called an order adapter. Its only job is to take an order object and figure out how to display its details in one of those rows you see.
Now, when you tap the button to add a new order, or maybe edit an existing one, the app takes you to a different screen, the Add Order activity. And this is just a simple form, right? A couple of text fields, a drop-down to pick a driver, and a save button. So let's just walk through the whole process. Step 1, you tap New Order. That launches the form screen. You fill in the details, pick a driver, and hit Save. Now here's where the magic connects. That Save button calls our OrderDAO's insert method, handing it the new order you just created. Room does its thing, writes it to the database, then the app pops back to the main list, which automatically refreshes itself from the database, and poof, your new order is right there at the top of the list.
We've looked at the individual pieces, right? The UI, the DAO, the database tables. Now let's zoom out and look at the complete picture, tracing the data from the screen all the way down to the metal. This diagram nails it. Look at the flow. The UI layer, our activities, never ever talks directly to the database. It only knows about the DAO. It just makes simple calls like orderDAO.insert. That DAO interface then talks to the main Room database class. Room then takes over, using its auto-generated code to run the real SQLite commands that save the data on the device. Each layer only talks to the layer directly next to it. That separation is everything.
And the thing that manages this whole connection is our app database class. It's set up as what we call a singleton. That's a fancy word for a simple idea. We make sure that only one single instance of the database ever gets created for the entire app. And this is super important because database connections are heavy, they use up resources. Creating just one and sharing it everywhere keeps the app fast and prevents weird conflicts where different parts of the app might be trying to write to the database at the same time.
So we've gone through all this effort to set up these different layers. We've got our UI over here, our data logic over there. You might be asking, why bother? What's the big payoff for all this structure? Oh, the benefits are massive. First, your code is way more maintainable. If there's a bug in the database logic, you know exactly where to look. It's also incredibly testable. You can check if your database code works without even having to run the user interface. It's robust. Room is designed to be main safe, which means it helps you avoid doing slow database stuff on the main thread that would freeze your app. It's offline first right out of the box because the data lives on the device. And finally, it's scalable. When you need to add, say, restaurants as a new feature, you just add a new entity in DAO. The pattern grows with you. So, there you have it. We've completely taken apart a modern Android database app, from the screen you tap all the way down to the data storage. We've seen how Room, combined with a clean architecture, gives you this incredibly powerful, scalable, and easy-to-manage foundation. So, now that you have the blueprint, what are you going to build?